Texas Math Mundo audience, today we add to our instructional series. Finding the area of a triangle in many ways is so critical in the Texas Competitive Math UIL Mathematics Contest and TMCA Contest. So today, finding the area of a triangle, and today we're going to use Heron's formula, a truly spectacular and beautiful theorem that you'll encounter on these contests every once in a while. And I look forward to showing you Heron's formula, especially in the context of some UIL problems. Let me take a quick moment and ask if you enjoy this content that you please hit the subscription button and the notification bell, that you leave a comment below, and that you smash that like button. I got plenty of beautiful things ahead in store for this channel. Heron's formula, a beautiful theorem on the area of a triangle, right ahead. My name is Saul Cantu, and this is Texas Math Mundo. Alright, Texas Math Mundo audience, today's addition to our instructional series involves Heron's formula. Heron's formula is a beautiful theorem, and it's a way to get the area of a triangle just given the side lengths of the triangle. Now, you should be concerned with the proof of this formula, and the best treatment that I've ever read on Heron's formula comes from the book Journey Through Genius. He has a whole chapter that places the formula in historical context. He develops a proof, and it gives you the flashes of brilliance required to accomplish the proof. And so Heron's formula, there's a chapter in William Dunham's Journey Through Genius. That's the best treatment I've ever read about Heron's formula, and it truly gives you insight to the true beauty of that theorem. It places it in historical context and everything. I would definitely recommend reading this chapter in this book. But for our purposes, we just have to know how to use it. So let's start off with a statement of the theorem. Heron's formula says that if you have any triangle, there's no restrictions on the type of triangle, that you can get the area given just the size of this information by taking the semiperimeter, and the semiperimeter is, as you would think, it's half the perimeter. You take A plus B plus C divided by 2, and then the area can be given by taking the square root of the semiperimeter times the semiperimeter times minus side A times the semiperimeter minus side B times the semiperimeter minus side C. And that beautiful theorem gives you the area of a triangle. Now, for our purposes, we want to see how this applies in Texas UIL competition. And so I have several examples. I'm going to start off with a simple one, just a straightforward application. But often, the use of Heron's formula is embedded in a more complex problem. And I'll show a couple examples of those as well. So the first problem we want to look at. All right. So the first problem we want to look at is straightforward application of Heron's formula. UIL 2021 release A number 7. It says find the area of a triangle, and they give you a picture even with the side lengths being 6 inches, 9 inches, and 11 inches. And so a quick, straightforward application of Heron's formula, you're going to have to find the semiperimeter. And so as you would believe, you take all the sides, 6 plus 9 plus 11 divided by 2, and you can quickly do this in your head. 6 plus 9 is 15, plus 11 is 26, divided by 2 is 13. Now, some people, it's an interesting programming problem. Maybe you'd want to program it. I mean, it kind of begs for a program to be written, but it's not that hard to do some of these quickly by hand. And so the area is equal to the square root, and we simply plug in the numbers of 13 times 13 minus 6 is 7, times 13 minus 9 is 4, times 13 minus 11 is 2, and we plug this into the calculator. 26.98, which to the nearest tenth is 27.0. All right, so that was a quick, straightforward application of Heron's formula. Nothing too incredibly difficult, but they get embedded in more challenging problems, and the next problem will be a more challenging problem in which you can use Heron's formula. The next problem, we're going to go to all the way back to 2008. So back in the day, they used to have a District Week 1 and a District Week 2. And so this was from the District Week 2 in 2008, and this is problem number 6. It says, a circle is inscribed in a triangle. The lengths of the sides of the triangle are 5, 8, and 11. Find the diameter of the circle. So a quick little brief sort of picture here. You got a triangle. You have an inscribed. This is going to be hard for me to draw here, more or less. All right, you have an inscribed circle. The lengths of the triangle are 5, 8, and 11. So I'm going to use a theorem, besides Heron's formula, that says that the area of the triangle is equal to the in radius, which is the radius of the inscribed circle, times the semi-perimeter. Heron's formula will give us the area of the triangle, and then of course part of Heron's formula is the semi-perimeter, and we'll be able to solve for the radius, but remember we have to double it because it asks for the diameter. So going ahead and using Heron's formula, the semi-perimeter is equal to 11 plus 5 plus 8 divided by 2, and 11 plus 5 is 16, plus 8 is 24, divided by 2 is 12. And so to get the area, we take the square root of 12 times 12 minus 11 is 1, 12 minus 5 is 7, and 12 minus 8 is 4. And this will give us the area, so let's pull out that calculator real quick. 18.33. Well, that is equal to the in radius divided by the semi-perimeter. Times the semi-perimeter. So we divide both sides by the semi-perimeter. And we'll get the in radius. All right. So on my calculator, I'm going to go ahead and divide that result by my semi-perimeter, which I calculated to be 12, and we got to double it. Remember, so that's the radius, and then we're going to double it. So times 2. We got 3.05505, and so that is answer D. Then we get that radius times 2 is equal to diameter. This is approximately equal to 3.055, and the answer is D. All right, so this is an example where Heron's formula is embedded in a slightly more complex problem, but you still need to use Heron's formula, unless there's another way to solve this problem, because there may be. So there you go, straightforward applications of Heron's formula. Now the next two problems, I'm going to give you a basic straightforward one, and then I'm going to give you a more complex one. And these next two problems, I would like you to pause the video, do the problem, put your answer in the comments below, and then you'll look at my work as I display it, and I'll probably put that in super speed. Okay, so let's take a look at the next problem. I want to go back to District 2021, number 45. So let me go find that. So this is District 2021, number 45. And let's take a quick look. They say, this is a straightforward problem. They say find the area of the triangle. They give you a diagram. Go ahead and one side is 7 inches, 5 inches, 6 inches. Go ahead and apply Heron's formula and get that area of the triangle. I suggest you pause right now. All right, so there goes the work. I hope you understood it. That one's a more basic, straightforward application of Heron's formula. Now for one that's more challenging, we're going to go to State 2016, number 58. And this one states, the length of the sides of triangle PQR are the roots of this cubic polynomial. Find the area, and the area of the triangle is K, and they don't even want the area, they want the area squared, K squared. What that means is when you get the area, you don't have to do the square root, right? So there you go. Pause your video, do it, and I'll fast forward my work, and we'll see what the answer is. All right. So first things first, I gotta get the roots. And there you go. I hope you enjoyed that treatment, 8 7/16. Remember, we just they wanted K squared. This is an application. 8 7/16 is your answer. That's our treatment of Heron's formula. I hope you enjoyed it. Area of a triangle in UIL math is very common in many ways. Today's treatment was Heron's formula. I hope you enjoyed that material. Okay, farewell. Awesome. I hope you enjoyed that treatment. Area of a triangle. I'm going to continue to do some area of the triangle instruction videos. You have to know many, many ways to get the area of a triangle, and Heron's formula is just one of those beautiful theorems that enables you to get the area of a triangle. Let me take a quick moment and ask that if you enjoy this content, that you hit the subscription button and the notification bell, that you leave a comment below, and that you smash that like button. I got plenty of wonderful things in store for this channel. I truly appreciate your support. My name is Saul Cantu, and this is Texas Math Mundo. Farewell.